Alright, so hello grade 9s. This is a video that's a follow-up on a live lesson that I did on surface area and volume. And so my hope is that you would have watched that live session that I did so that you can actually get more out of this video that I'm now doing. So we are going to look at a cube, alright? Because we didn't look at it in the live lesson that I did, and we are going to look at the cylinder as well. Alright, and please take note of my other additional video that I will have done on the explanation of the cylinder and the formulation of the formula of a cylinder for surface area, so that you can understand it practically, how it is formed, the formula in and of itself. So a cube is obviously a three-dimensional shape. It has, right, sides that are equal in every dimension, whether it's the horizontal, the vertical, or the other plane. So we denote a cube having squares as its faces, and as a result, this length would be s, the breadth would also be s, and then the height itself, yes, the height, all right, would also be s, meaning the sides of the squares that you have, which in total you have how many square faces in a cube? You have 6 square faces, and the area of one square is actually s squared. In other words, it's side times side for one square. And that would mean that if we are going to calculate the total surface area, we are talking about 6 faces of the square. There's the face number 1 with face 2, this face and this face, which is 2 faces, they are the same. The front face and the back face, which are also the same, and then the top face with the bottom face, which are also the same. So therefore, you could say then in essence that the total surface area of a cube is 6 times the area of one square face. So 6 times s squared, it would be 6 areas of the square, 6 faces of the square. So you calculate the area of all 6 faces of the square, so we can say it's 6 times s squared. The volume, on the other hand, of a cube would be, we know that for any volume of a prism, okay, and by prism we then believe that there is the base in which you place that prism will have a congruent and identical shape or two-dimensional shape at the top. So since it's a cube at the bottom, which is the base, then you are going to have the same cube at the top. Since it's a square as your base, then you'll have the same square at the top. All right. So in other words, volume, we know, is calculated by the area of the base of the three-dimensional shape that you have times how tall or the height of that particular three-dimensional solid. So if you look at the cube here, what you have as the base is a square. All right, you have a square base. All right, so therefore we are going to say that the volume of this cube is going to be side times side, because that's the area of the base. Then we multiply that with its height, how tall it is. Now how tall it is defined by this particular length. So we are going to say the volume of the cube is actually s squared, the area of the base, which is a square, times its height, which is times this s. So in other words, it's like saying s times s times s, which is s to the power 3. Hence the volume of a cube is s to the power 3, because the first s times s is because of the area of its base, and then the times the what? Times the height, which is the third s. So if you multiply these 3 s's, it's like you get s to the power 3, which is basically the volume of a cube. So you would multiply the respective dimensions of that cube to get the what? The volume of the cube. Moving on to the rectangular prism. The rectangular prism has how many faces? So it has this side face, which is congruent to this side face. Its dimensions are the height, which is how tall the particular rectangular prism is, and then you have times its what? The breadth here, which is this rectangular face, which is congruent to this rectangular face. So we have two rectangular faces that have the dimensions h and b. These are the dimensions. So if you're calculating the area of this rectangle, then it's h times b, but remember there are two of them. So that means you are going to have 2 what? H times b, or b times h, because multiplication is commutative. Okay, so the order of multiplication doesn't really matter as long as we are featuring this. Okay, so there's 2 of those rectangles. Look at the top and look at the bottom. The top rectangle has the dimension. Remember, rectangles have opposite sides that are equal, so this would also be b. And then this here would be the same as that there, would be the same as that there. So that's L, 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 which is the length. So this means that this is b times what? B times L. So you are going to have this rectangle at the top, which is a b times L rectangle, which is also here at the top a b times L rectangle. So therefore we say that b times L, or L times b, 2 of those rectangles. We also add to the 2 times b times h. Let's conclude. We have this front rectangle, which is also the same as this back rectangle. Makes sense? So that back rectangle and front rectangle have the dimensions length and here the height. So the length and the height, okay, because remember this is height, that would also be height, that would be also be height. So that's length times height. So therefore you have another 2 length times height. The summation of all of these rectangles is 6 in total, but a pair is identical or congruent. So therefore you would add that to get the total surface area. 6 rectangular faces, 2 are identical, and therefore you are able to add those all together to get the total surface area. If we move on to the volume, once again the concept of volume for any 3-dimensional shape that is a prism has a similar base, and at the top you see this congruent one would be the area of the base. Now let's look at the base here. What do we have as the base? We have a rectangle. Okay, it's resting on the floor with this base, length times breadth, base at the bottom. So length times breadth, this length times this breadth. Okay, this rectangle has a congruent rectangle at the top. So this is really the base. This is the rectangular base that is the same as well. This is the rectangle that is similar to the base. So if we want to calculate the area of the base, we are going to say area is equal to length times the what? The breadth. That's the area of the base. Then we multiply it by the what? By the height. So the height would be h. So that's why we say length times breadth times the capital letter H, height. That gives us the volume of a rectangular prism or a rectangular box. Hope that makes sense and it's clear. Let's go to the triangular prism. For the triangular prism, guys, we have 2 triangle faces, the front and the back. Now a triangular prism, you can see even in the name, triangular prism means the base that this triangle would rest with, which has a similar triangle at the top. The triangular prism, by the fact that it's triangular prism, means that the base is a triangle. Rectangular prism, the mere fact that it's called rectangular prism means the base should be a rectangle. The fact that this is a cube and we know that it's made of square faces, it means that the base must be a square. Cylinder, the fact that this is a cylinder and we know that cylinder kind of also refers to kind of like a aspect of circle, then we know that the base is a circle and there's this identical or congruent circle at the top. So let's look at total surface area first. Total surface area, we're looking at how many triangles. 2 triangles, they will be the same. All right, so we know that the area of one triangle is half base times, now look, this base refers to the base of the triangle. Okay, please guys, this idea of base, as we are speaking about just the triangle itself has its own base as a 2-dimensional shape. So the base, all right, times the what? The height, not the height, capital letter H, of the entire 3-dimensional shape, but the height of that given rectangle. So in this, that given triangle. So in this case, right, since this is an acute angle triangle, we know that the height will be internal to the triangle. If obviously, let's say for instance, this was the type of triangular prism that has right angle triangles as their triangles that are bases, then we would obviously take that into consideration, because the height is actually there in the triangle if it's a right angle triangle. So we always consider the type of triangle that we have, and remember, okay, that there are 2 of these triangles. They are congruent, meaning they are exactly identical in side and in angle. So we would say 2 of those triangles, half base times height. Okay, that's the 2 triangles taken care of. Now there are additionally how many rectangles? There's this rectangle complemented by the side of the triangle, this side of the triangle. There is this rectangle, this one, okay, second rectangle, and this side is a dimension of the rectangle, and then there's this rectangle here that is also a rectangle that is complemented by the side of the triangle. So you can see each side of the triangle has a rectangle that it actually goes with. You see, I hope you understand this. 1, 2, and then this rectangle 3. So that's why we say plus the area. Now you know an area of one rectangle is length times breadth, but then you are going to calculate the area of 3 rectangles. Now guys, these rectangles can be the same rectangles if the sides of the triangle, let's say if the triangle here is an equilateral triangle, then of course this rectangle, because this height will go for the rectangle here with this side, so you would multiply this with the height, then this rectangle, still it has this height, this side would be equal to this side if it's an equilateral triangle. Then this rectangle, still this height would be a dimension multiplied by this side of the triangle. So you would have 3 rectangles that are identical and that are the same. But if the sides of the triangle are not equal, then it means the rectangles will not be the same. But if the sides of the triangle, you have 2 sides of the triangle equal, then it means 2 of the rectangles will be the same, 1 will not be the same. So these are things you need to look at when you are calculating the total surface area. That when you calculate the area of 3 rectangles, you may have a situation where you have to separately identify the area of each rectangle, the area of this rectangle, taking note of this dimension with this dimension multiplied together, the area of this rectangle, taking note of this dimension and this dimension being multiplied together, and then the area of this rectangle, taking note of this dimension and that dimension being multiplied together, and then you add everything together, the area of the 3 rectangles together with the area of the 2 triangles. That's how you calculate total surface area of a triangular prism. Okay, I hope that makes sense. Then what about volume? Volume of a triangular prism. Once again, what did we say volume is? It's the area of the base. What is the base of a triangular prism? It is the triangle. Because I can take this triangular prism and make it rest on the triangle, then I can have the identical triangle at the top as well. You see that? You see how those things complement each other? So then you can then say the area of the volume of a triangular prism is the area of the base. Obviously, one triangle is half base times height, so we are looking at the area of the triangle, which is half base times height, just one triangle. The area of one base times its height, okay, how tall this triangular prism will be when it rests on its base. This would be how tall it is, the height. Okay, all right. Then lastly, cylinder, grade 9s. Cylinder, if you're talking about the total surface area of a cylinder, please guys watch the other short video where I explain using a paper how we basically formulate the area of a cylinder, the total surface area of a cylinder. So if it doesn't make sense to you when I explain it now, please guys go watch that video. It will be in the playlist where I will place all 3 of these videos that have to do with volume and surface area. But anyways, the area of a cylinder, the total surface area of a cylinder, guys, is 2 pi r squared. Where does the 2 pi r squared come from? Remember, there are 2 circles, one at the top, one at the bottom. When these 2 circles at the top, this top part is closed, then you have a circle at the top that is closed. You can calculate its area. One circle's area is pi r squared. The minute these 2 identical or congruent circles are taken into consideration, you want to calculate the surface area of both, then you have 2 of these circles, which is 2 pi r squared, okay, when they are closed, all right, surfaces. Then additionally, we have this 2 pi r h, right? In the video where I show you guys in the playlist how this part is formed, you can see it more clearly what I meant. Okay, so please do take the time to actually watch that. But just something to note here, remember I said there are these 2 circles, right? So that is the total surface area of that's the surface area of the circles when they are closed. So if I was to actually open this up, okay, if I would open this up, this is what you would actually see for the surface area of this part. You see this part. If I would open it up, all right, this here would represent the circle, you know, because it would represent the circle there. So I want you guys to please go watch the video, okay, where I actually explain this. But this side would be 2 pi r because it represents the distance around the circle, okay. And then here, this height would be the distance from the bottom of the cylinder to the top of the cylinder. That would be height. But remember, the actual surface is going to be a rectangle, so therefore you would say the length, which is height, times the breadth, which is 2 pi r, so it becomes 2 pi r times the h. Guys, in order to make a bit more sense of this thing here, please go and consult my video that I've actually done where I'm explaining to you visually what a cylinder is using a paper, and then I explain the concept of the 2 circles together with this concept of how this is formed, okay, so that you can get clarity there. Then lastly, the volume of a cylinder. Guys, the bottom part of this cylinder is a circle, so that means that the base is a circle. Therefore, the area of the base times the height is what volume is. The area of the base is pi r squared, because one circle is pi r squared, times its height, how tall, the height times h. And that's it. The formulation of these formulas is as simple and straightforward as I've just explained it to you. And please guys, go get clarity a bit more from my video, or I will insert it here midway so that you guys can get that clarity about the cylinder. Okay, now to get into some problems so that we can now address specific problems. All right, in my long video I did problems on rectangular prism and triangular prism. Now what I want to do now is look at problems that have to do with cylinder and cube, so that at least we can have a bit more clarity on that where surface area and volume are concerned, and then we can actually then at least say that we have covered the bases that need to be covered. So if we look at a question that says find the volume and surface area find the volume and surface area of a cube with length 8 centimeters. Now we can see nothing is drawn for us here, but we are just given a statement. Obviously from the statement, guys, there needs to become a visual representation in our heads of what they mean by this. Okay, so I mean, you're not expected to be an artist. Two rectangles, two squares like that, and then it's a matter of connection. There's our cube. They're saying the length is 8 centimeters. So length I know is kind of like this side. So if that is 8, guys, since this is a cube, we know for a fact that will also be 8, and that will also be 8. So we are going to have all dimensions being 8 centimeters. Now we want the what? The volume of the cube. Remember, what did we say volume is? Volume is equal to the area of the base. So the area of the base here is going to be side times side, the area of the square at the bottom. Then I'm going to multiply it by what? By the height, which is also 8. So I mean, guys, really we can say s times s times s, which is s cubed. So that means we're going to say 8 cubed. Okay, 8 cubed. We put it in the calculator. Hopefully you guys in the comment section will let me know what the answer is. Okay, so that I can see that you guys actually did take the time to watch this video. And the most important thing here, guys, is that since we said centimeters, we need to then make sure that our answer is in what? Centimeters cubed. So I'm going to leave this so that you guys can in the comment section let me know what 8 cubed is, so that I can see that you guys did really actually watch my video. Right, let's move on to the next question. Okay, oh sorry, they wanted us to also calculate the total surface area. So TSA, is the total surface area is equal to what? Now remember, we said we have how many square faces? 6 of them. 6 square faces, and we know that the area of one square is s times s, which is s squared. So we're going to say 6 times 8 times 8, or 8 squared. Okay, and then obviously, guys, you should be able to punch this into your calculator and get the answer. So once again, I am not going to actually tell you what the answer is. You guys in the comment section will let me know what you got as your answer. But that is basically going to be, remember, in square units, guys, that will be centimeters squared, and we leave that as our answer. Okay, then I want to do the following question. Let's say we had a question like this: calculate the volume and what? And surface area of a cylinder if its diameter is 7 centimeters and its height is 20 centimeters. Alright, and then here they specify that give your answer correct to 1 decimal place. Okay, so once again, this is a cylinder. We are told that its diameter, now very important here, that we are told its diameter is 7 centimeters. If the diameter, guys, is 7 centimeters, remember what diameter is that for your top circle, if the diameter is 7 centimeters, then diameter is equal to 2 times the radius. That's something we need to note. Okay. Diameter is equal to 2 times the radius. So in other words, if we want to calculate the radius, we are going to say radius is equal to the diameter divided by 2. So if we want the radius here, we are going to say 7 centimeters divided by 2, which gives us 3,5 centimeters. Because we know in the formula for volume and surface area, we don't have diameter, but we have what? We have radius. So we do that to help us out. Then we can come here and calculate the total surface area. We know that there are two circles, right? So the area of the 2 closed circles will be pi r squared, so we multiply by 2 because there are 2 circles. And then remember, we know that the lateral surface of that cylinder will have the dimension that is 2 pi r, which represents the circumference of the circle. We multiply it by the what? By the height, which represents the dimension, that is basically the length or the height in the situation of the cylinder. So then we substitute that 3,5, you see, and we don't substitute 7, we substitute that 3,5. Remember, the height we were told is 20. Something else we note here is that we check if the units are actually written as being in the same unit. Because if, let's say, this was in millimeters and this was in centimeters, then it becomes imperative for us to do our conversions. We need to always make sure, guys, that our units are the same. Kilometers to meters we times by 1,000, meters to centimeters we times by 100, centimeters to millimeters we times by 10, and then vice versa. If we want to go from millimeters to centimeters, we divide by 10, centimeters to meters we divide by 100, meters to kilometers we divide by 1,000. And if we want to go from millimeters to centimeters, then we divide by 10, we divide by 100, we get there. And so it goes. So just make sure, guys, that when we substitute values here, we have the same unit. So centimeters, this is in centimeters, so it's easy to substitute. But if we don't, we always convert first. And then you guys will go to your calculator and tell me what the answer is in centimeters squared for the total surface area. Then lastly, let's just calculate the volume. We know that volume is area of the base, which means pi r squared. We multiply that with the height, so that would be pi in the place of r. We know we calculated r, and then we multiply it by the height, which is 20, and then we use our calculator, we substitute, and then we should get an answer. You guys, please, in the comment section, let me know what the volume of the cylinder is. Let me know what the total surface area of the cylinder is. Let me know what the total surface area of the cube is, and let me know what the volume of the cube is specifically in the comment section. But I hope the approach and the method, you guys are able to at least understand what I did there. Okay, thank you very much. I hope you enjoyed this video.